In this video, I'll demonstrate how to create a plot data table using logarithmic x-value increments, better suited for curve charts featuring a logarithmic x-axis. In previous videos, we've created plot data tables that span the range of the calibrator x values using linear increments. For more information on creating plot data tables, please see the associated videos. For typical 4PL and 5PL curve fits, the chart is displayed on semi-log axes, with a linear y-axis and a logarithmic x-axis. I have open an example data set with my 4PL curve fit coefficients calculated, and my fit plotted in the curve chart. This plot data table was created using a linear increment for the x value. The curve chart looks great with a linear x-axis, but you can see when we update the x-axis type to logarithmic, there's a large section of the fit that appears linear. To address this issue, we can improve the appearance of the fit line by updating the plot data table to use a logarithmic increment for the x-axis values. Recall the plot data table uses the calibrator minimum and maximum values in the above equation to automatically update the x and y values based on the calibrator x value range entered here. To create a logarithmic increment, we need to first calculate the log of the maximum and minimum calibrator values. To do this, I'll enter equals log and select the minimum, and I'll enter the log base 10. Next, I'll do the same with the maximum value, equals log maximum value base 10. To simplify the formula calculating the x values, I'll calculate the log increment. I'll enter equals log max minus log min divided by 100. Now for our plot data table. In our new plot data table, I'll have two x columns, x and x prime. The x column will calculate the log of the x values to be plotted, and x prime will use the power function to return the x values to actually be plotted in our curve chart. In the x column, for the first point, I'll enter a cell reference to report the log of the minimum calibrator value. In the subsequent cell, I'll enter equals and select the cell directly above containing the log of the minimum calibrator value plus the log increment. I'll enter F4 to make the reference to the log increment value an absolute reference. Now we can drag the formula down to include 101 points. This will span the calibrator range. In the x prime column, I'll enter equals power 10, and select the corresponding x value. This returns the minimum calibrator value, which you can see here. I'll drag this formula down to fill the remainder of the cells. And you can see the last data point here contains our maximum calibrator value. So this x prime column contains x values to be plotted that span from the minimum calibrator value to the maximum calibrator value in much the same way as our original plot data table, with the difference being a logarithmic increment between each point as opposed to a linear increment. Next, I'll calculate the corresponding y values. To do this, I'll enter equals MyCurveFit 4PL calc y. I'll highlight the values of my four parameters, press F4 to make this selection an absolute reference, and highlight the corresponding x prime value. Pressing enter calculates the y value, and now I can drag this formula down to calculate the y values corresponding to our x prime values. Next, we need to create our curve chart. I'll highlight the x prime and y values and select to insert a scatter chart. I'll format the data to be displayed with a solid, smoothed line and no markers. Next, I'll add our calibrator points by right-clicking and selecting Select Data. I'll add a new series named Calibrators and highlight our calibrator X and Y values. I'll format this data series to contain no line and automatic markers. Now our new curve chart has been created, and when we update the x-axis to a logarithmic scale, You can see the CurveFit display is much improved, with the fit line following the calibrators as expected. Moving this chart back to the top of our report, we can compare our two curve charts with a linear increment versus a logarithmic increment. You can download a copy of this example spreadsheet from the below link. If you have any questions about how to create a plot data table with logarithmic x-axis increments, please email us at support@myassays.com.